Hello and welcome to this PV Tech Talk product series webinar, co-hosted with Sun and Steel Solar. The title of today's webinar is How Simplistic Tracker Design Can Deliver Competition-Busting Cost Benefits. My name's Liam Stoker and I'll be your moderator for today's webinar. And joining me today is Robert Daly of Sun and Steel Solar. Before we start, some housekeeping. Today's webinar will last around 1 hour. Shortly, we'll have Robert open proceedings, followed by a presentation exploring Sun and Steel's design principles, its benefits over more complicated designs, and some of the pitfalls that you may see with overcomplicated tracker mechanisms. We'll then have a short video, which will add some color and context to the presentation, after which we'll have a short audience Q&A. If you do have a question, please use the dialog box on your screen. We'll work our way through as many questions today as we can, but if we are unable to get around to your question, if you could leave your email address, we'll aim to liaise with you directly as soon as possible. The slides and a recording of today's webinar will also be available shortly after the presentation, so keep your eyes peeled on your inbox and on PV Tech for that. But without any further ado, I'll hand over to Robert to begin today's webinar.
Well, thank you, Liam. As Liam said, we are Sun and Steel Solar. We started 3 years ago in 2017, and we have a simplistic tracker design that's going to, really reduce the cost. Again, it's just the lowest cost tracker, and it's not by cutting corners, but by doing it with simplicity and intelligence, true concurrent engineering methods. This is a better mousetrap. This will save $30 million per gigawatt upfront and $50 million per gigawatt over a project's lifetime, compared to all the competitors out there. And it's not by me just thinning out metal. I will explain everything throughout. Briefly about me, I've been in PV. First off, I have a BS Electrical Engineering, BA Spanish, and an MBA. I've been 42 years in the PV industry, starting at Arco Solar in 1979. I know what you're all asking. What's a fossil doing in the renewable energy industry? Well, I'm here to bring on a lot of intelligence and experience and good practical knowledge. For 13 years, I designed solar panels for satellites where things had to be done right the first time. And 28 years in the terrestrial PV, as high as director, CTO. And I started my own company 3 years ago. 2 previous tracker developments, one for Shell Solar and one for Conergy, which saw 600 megawatts. It ultimately became the AP90 for FTC Solar, which was retired 3 years ago. As I say, 13 years designing solar panels for satellites, and then 17 years of tracker development. And my first tracker, a 1 megawatt for Shell Solar, is still operational, and I stopped to buy it this year. That's in the lower left and the lower center. And in the lower right is a 24 megawatt for Conergy with my tracker, my second tracker design. The first one I really did in collaboration with a good colleague. That's 24 megawatts in the lower right. Each one of those rectangles is the size of a soccer field or football field. We are a startup. This is perfect for C&I and grid solar farms. We have 2 patents. And both of those patents are strategic in that they reduce cost and enhance the reliability simultaneously. And so we are seeking a round A funding of $2.5 million for 25% ownership or equity in our firm. That would make you the 20th investor. We have 18 investors plus me. This is a great opportunity, and we're in a growth spurt right now, but we are pre-sales. The perfect investors would be an angel of venture capital or private equity, because we see the upside in the long term of this. We can get this to a very high level M&A or an even IPO. Of course, the fixed tilt racking companies and tracker companies and PV module manufacturers wanting to go downstream, steel companies, EPC, all of these would be great investors for a round A or even an M&A. We are open to an M&A of roughly the same value, but there is about $2 million more to finish this off and get it to market. Other potential investors are all the stakeholders in every solar farm there is, including the ag industry, companies putting on very large pieces of glass on buildings, etc. And how about some of those entities like Mastar, DEWA, Aqua Power? The investor is out there, and that's the intent of this presentation. First off, I want to teach you about single axis tracking. It delivers this much more energy compared to fixed tilt. Fixed tilt is the red. The tracker, it tracks the sun, gives you a little more, and backtracks in the morning and late in the afternoon. Goes basically east to west. That backtrack, this is your gain, that blue shadow, that's a gain in energy. At any moment in that day, that's the gain in power at that moment. You see over on the left, there's a lot of shadow on the ground. That's the purpose of backtracking, to maximize the sun on the PV and minimize the shadow on the ground, the sun on the ground. But you don't want that shadow to creep over to the next row, because then it really affects your output. What's beautiful about single axis tracking is that it shines light on the aisles and the PV in the midday, from late morning to early afternoon, so that you can grow agriculture down those aisles every single day, 365 days a year, except of course when it's cloudy, but the sun does shine there. Here again is showing backtracking, and some people want to minimize that light, that little band of light on the ground, and you're not going to get that much more. The sun is very low in the sky, maybe delivering, say, 10% energy at a high incidence angle. And gee, if you've got 4 inches of light on the ground over a 400-inch cord and row, 800 inches, that's minuscule loss. It's best just not to shade each row and have this little buffer. That's what we do. Just briefly, a lot of people claim single axis tracking can deliver up to 30–40% more energy than fixed tilt. That is true. Would you believe me? You probably wouldn't believe me. We all know it's about 20–22% in the high areas and 12% in Northern Europe. But look, over in the summer months to the right, this is in MENA, Middle East, North Africa. You're approaching 40% in those summer months when you could have a time of use. Air conditioning is blaring. This is what's beautiful about single axis tracking. The additional, and there's one more gain you can get, and that's the gain to grow agriculture down the aisles. Why confiscate ag land when you can share it? Northern Europe, say Northern England or even England, why would they only want 12% additional energy for tracking? Because now the trackers are so large, it allows you to get to those weeds underneath. And O&M is a cost. What is the main issue with tracking? It's all about cost. The material, the logistics, getting it all together, the EPC putting it together, O&M, that's OPEX for 30 years, and of course wind. Wind adds all sorts of cost. You have to strengthen it up, add Band-Aids, and then there's a risk factor with that, which has to be calculated in. What is the solution to these 5 issues? You make it simple. Simpler the easier. The simpler and easier, the lower the cost. Simplicity throughout makes a OPX that's just very easy to do. It's like the Maytag repairman, nothing to do. And the wind, you need strategic simplicity and strength for a truly bankable ROI. We'll get into this. If I break down those costs into components, it's this. It's the piers, bearings, torque tube, drive, system, PV attachment, the control, turning it east and west and stowing it, the wind, of course, the EPC and the Opex. We avoid all these complications which add cost. You know, the piers, people have one choice, we have multiple choices. Bearings, everybody's making them tight and slippery with plastic bushings and complex. Torque tubes have facets, either square or octagon, or they forego torque tubes and have just a flimsy table, have taken their fixed tilt and put it on a tracker. Elaborate drive systems that are risky and require strict alignments. You can read the rest of this, and I'll show you how we're going to fight all of this. Our fight will bring this to that $50 million per gigawatt savings, 5 cents a watt. And I tally it out here on each one of those items. Every one of these starts off with the word simple, basically. The piers, non-hot dip galvanized, and we have optional materials I'm going to show you. The bearings, they are just steel on steel, a loose fit. It's just a guide to hold the torque tube in place, even non-hot dip galvanized. A torque tube, non-hot dip galvanized round. We have a patent on this because round is stronger than square by 33%, and we have a protruding weld seam or added material to give us extra stop if needed. But a very big round torque tube gives a lot of friction for holding of the panels. Drive system is cable, leveraged, pulley, durable. PV attached, we have a unique way of doing this that's faster, simpler, and on down the line. The main thing is a control. One PLC, off-the-shelf programmable logic controller for an entire field, not one control per row. And then on our wind, we have a self-locking bearing that's just magical. EPC, we're going to make this easy for you. I grew up in the construction industry. I know what this is all about. I've seen people beat trackers together because things just weren't right. And of course, Opex. P-cost issues, it's complex, difficult, congested, inconsistent quality when they put it together. Difficult PV attachments, you can see over on the right, guys on their knees. Is that really how you want your crew to be working? Unpredictable durability and reliability. We've seen them fall apart in the wind. I've seen solar fields where every tracker row is pointed in every which way except at the sun. And then a costly O&M, especially with the weeds, if you're this low to the ground. And then underestimated 30 years of ownership. If you really remove the risk by having a Timex watch that just keeps on ticking, then this lowers your LCOE. This is complication. I did a 21 megawatt project with someone else's tracker. It was, I was owner's engineer. I watched the two splines of a turning drive shaft not fit together, and the contractor's worker beat it with a hammer to make it fit, and he broke open the universal joint. Bearings on the ground, latent defects just waiting. Slippery bushings, and then you add on a damper or a car strut to dampen it out, and then a wing to spring to compensate that. Complication is not needed. Truly, the lowest cost is not just material only, but it's Capex, the material, EPC, putting it together, and then 30 years of Opex. And you do this with foolproof simplicity for the lowest, absolute lowest LCOE. This is what we have going on. It's me on the left at our test site at Cal Poly, San Luis Obispo, where we tested 2 full-size roads prototypes. The other 3 are renditions of our final product. Simplify everything. Piers, how am I going to get you 0.2 cents per watt, $2 million a gigawatt savings? We have 3 options. My first one on the left is telephone poles, wooden telephone poles, 480 of them. Just drilled a hole and filled it with cement slurry. The middle one, it's a 40 megawatt fixed tilt in Vietnam. It's my idea also of what I call concrete earth nail. It's reinforced concrete. In case your steel just goes sky high, they can fabricate this anywhere. And then over to the right is a 7 megawatt system in Folsom, where we did not hot dip galvanize the post. This is with my second tracker for Conergy. By then it was Solar in Korea. I was CTO. And in most environments, you do not need to hot dip galvanize. And you'll see that on the bottom of trains, military tanks, many places. If you're thick enough, it just develops a patina. So we have options and cost reductions. Non-hot dip galvanized post, as I mentioned. These are the wooden posts at that 1 megawatt solar farm. This is a picture from March this year. 17 years later, those wooden telephone poles are still holding. Down below is pictures from 17 years ago when we built it. 48 rows and wooden telephone poles throughout. The bearings, this is our coup d'etat. We tested steel on steel. It's a simple bearing. It doesn't wear itself out. It's a loose fit. We don't have to have tight alignment. It seats itself in. That steel on steel gives a perfect friction for damping. You can not hot dip galvanize it or the hot dip galvanize the pieces. We tested both, as shown on the left picture is the hot dip galvanized bearing, and on the right. And since then, these bearings have been much simplified, and they give the electrical ground path naturally, so you don't have to add on a ground wire at each single post or a shock absorber at each and every post. And the integral north-south thrust stop is in combination with the east-west tilt stops, and it also stops it from lifting up. And it actually pinches the bearing tighter on itself as the wind increases in speed. Can you imagine that? The wind actually dampening itself. This is patented. We've received a patent on that. Our simple bearing, the picture on the right shows after 22,000 cycles back and forth, that's 30 years of operation. The steel just scratched itself a little bit. It does not wear itself out. Can you imagine a bearing with self-regulating damping, a wind that dampens itself? That's what we have come up with. Just a quick few pictures that we're working on we have two options for the post. It can be just a C-beam, which we've used before, or this one piece shaped piece of strap. Two identical pieces, they intertwine and marry, and then we put in our torque tube with the thrust stop with the holes in it for putting in bolts for the integral tilt stops. And actually, we don't even need that top brace to hold it in. It'll hold itself in, but it's there for good measure. And as it lifts up, it squeezes that bearing race on the journal that's turning inside, increasing the friction, increasing the clamping, increasing the holding in the wind. This is a close-up view of how far we've gone along. This is a 4L system, 4 in landscape. There's a 4 in landscape and another view of our bearing, another close-up view of the bearing, 2 torque tubes, the journal coupler inside, the bearing race is red, and the journal couple also has the flanges for the thrust stop, which is also the bolt makes a tilt stop. The torque tube, we have a patent on this. So to recap, we go from the post to the bearings to the journal couplers, and now we're going to couple those torque tubes together with that journal coupler. We have 9 of them in between these 10 posts. We've tested all non-hot dip galvanized because it's pretty hefty, and it worked like this is Cal Poly San Luis Obispo, our test site, as we're building it up. This is it. Over on the left, we use simulated solar modules, frameless solar modules. Those are 1 meter by 2 meters pieces of glass, 4 of them glued to 2 purlins to make a panel, a pre-panelized panel or pre-assembled panel that's 2 meters by 4 meters. Over in the right, it shows what attaching to a pre-panelized panel looks like. That happens to be a 2P, a stack of 2Ps, and they just slide right over onto our round torque tube. One more thing, and those round torque tubes, they act as trolley rails, which you will see, which you could see the trolley in the lower right corner picture delivering stacks of pre-assembled panels to the waiting forklift. Or that trolley could just load those onto the torque tubes itself in case that aisle is muddy and you can't get that forklift or grate all or whatever you want out there, or vacuum suction lifting. Another picture close-up showing the shuttle system, and that shuttle can either shuttle pre-assembled panels or crates of modules, and the guys can stand on this platform with safety and put on single modules at a time. Lots of options. Always faster, better, cheaper is the best. The drive system, so unique here, so much heritage. We have a small slew drive with 2, it acts as a winch. It has 2 drums, about 1 foot in diameter. And it has 2 cables, 2 redundant cables going both ways into 2 large half pulleys. That's an 8-to-1 leverage to that small slew drive. That slew drive, when you hook it up to the cables to the 2 half pulleys, it just hangs by itself right in line and with the perfect tautness on the cables, and then you clamp it down to the 2 posts. Those 2 posts, inner posts, are about 1/2 meter apart. That is our drive system, redundant, robust. We purposely ran this out of alignment with the cables pulled far to the side, and it just could not fail. And the other beauty of the system are there no moving wires. All the wires to this system are on the stationary bottom side. No tilt indicators. Just durable, easy to set up, and main thing is durable. Again, this is what it looks like, and you can read this later. We have the option to have openings around it. Maybe you want one gap of PV on the side of it so that when it's tilted 45 degrees, when all rows are tilted 45 degrees, you can walk from motor to motor, row to row easily. Or you could have 100% topside coverage, which is a maximum efficiency for a solar farm. But we do have to think about OpEx, so you might want to miss one group of modules, or put some sort of gap in there, either for an ATV or for a person. PV attached, this is again where we shine. This is picture on the lower left is that Shell Solar 2004 project. We pre-panelized 6 modules and 2 purlins, made a 3.3 meter cord. That was small modules at that time, 0.55 meters wide. We've pre-assembled them at the factory, put them into these racks, sliding racks, which carried 10 at a time. The truck carried 8 of these racks, unloaded them. The guys just pulled them down the aisles and slid them right off onto the torque tubes. It works, and we can do it for 2P, 3L, 4L, or even 5L. 2 in or mini in landscape. We're patent pending on our sloped purlin. Our sloped purlin can be sloped like it shows on the right, or it can even be coplanar as shown on the left. The beauty of the sloped on the right, it's very small cosine loss of 6 degrees, 5 degrees. It prevents sediment ponds. It helps with the wind uplift, and it is aesthetically beautiful. And we'll find some more as we go along. We tested coplanar at the site. We also did do a small contingent of tilted up and down. Again, this is showing the trolley to attach those pre-assembled panels. I don't know why I'm showing this again, except that on the left it shows at the Cal Poly site how we had pre-assembled those 2 meter by 4 meter panels, I call them. That's 4 simulated modules and 2 purlins. And then we used a forklift to haul them over to the torque tube to simply quickly put them on. Here's a little comparison view on the left showing coplanar versus this is a 5 degree tilt up and down. And then over on the right, we've put 6 of them together. Those are SunPower modules, 1 meter by 2 meter modules. This is what a pre-panelized system might look like for a bifacial 2P. Both purlins are out on these long sides of the module frame, which isn't ideal, but doable. And so this fully opens up the backside for bifacial. We can also go 3L, 4L, 5L, multiple Ls, and that can also be done with bifacial in a much more efficient way than the 2P, and I'll show that. The control system, this coup d'etat here, again, we have 2 options. We can use an off-the-shelf controller. There's many suppliers out there, and we have done that for our test site. Or we've done what we've done in 2004, one off-the-shelf PLC controller that just sends out a timing signal. Motors go on 8 seconds. Okay, now go off, wait 5 minutes. Okay, motors go on for 7 seconds east. They all get the same control. It's the same move signal. And it's a very low cost. No wireless, no controller at each place. The PLC is in a control room or can be out in the field in a box. No batteries, no wires, and no inclinometers. The feedback is your PV output. And there's no moving wires. And the main thing is this is going to really lower cost, increase reliability, and make it fully hardened. Nobody can hack this. Cost savings number 6. So then what I just said, this is it, and it's patent pending. This is how simple it is. The other beauty is we could have a plus or minus 5-volt wire going out to each one of those boxes in parallel with the power supply out there, which could be your battery and PV panel, or it could be hardwired AC from a distribution system. We plan to put that go east, go west signal on that power line. So it's a power line carrier. We have a partnership with a company in Northridge, California, PLC Lighting, who has a unique technology that fires a small capacitor at each and every zero crossing, either fires it or doesn't. It gets charges 120 or 100 times a second at 50, 60 hertz, and it fires or doesn't fire and gives reliable information throughout a very large network, and it does not cross across transformers. So you can control 100 megawatts with one PLC, and that's what I looked at last March. Our 17-year operational PLC is still operational. East-west elevation changes. Our tracker is best for big flat farms, deserts, agriculture, fields. You do occasionally have this up and down problem, and you're going to have a problem during backtracking, as it shows there with so what people do is they put in fancy backtracking that requires a wireless and talking to every one and knowing exactly what angle that is at. Okay, we fixed that, but now backtracks more, and no, the next row is shading it again. Oh, so now we double fancy backtracking software, and it's complicated. Elaborate software, shadow detectors, literally a special solar panel that says, hey, here's how high the shadow is. The tilt sensors, many local controllers, one per row, a wireless net, complication, cost. Here's what we do. If you have an occasional up or down, you just space that one row out. Give a bigger aisle there. Solution solved. Problem solved, problem solved during, well, that was during tracking and backtracking. And now in the morning, during backtracking, no problem, of course. Tracking is no problem. And the problem solved, then you do that up front at the design stage. Wind, this is what everybody is concerned about. What are you going to do? The history is here. We had very strong systems. That 17-year-old system, 1 megawatt, doesn't do any stowing for wind. It just built so strong, it just operates no matter what. Then people thinned out the metal and it started failing. So then they added dampening, which had limited effect, and they still had failing. The trackers just zipping apart in 2P, one purlin pulling the next adjacent set of panels. And so what has happened, they've now added drives to each row. 1 gigawatt, say you have 50 kilowatts per row, 1 gigawatt is 20,000 rows, that's 20,000 drives. If you put a drive on each row connected with spinning drive shafts, only one of them is motorized, but the others are powered by that spinning drive shafts. Now you have 9 times as many drives. Your gigawatt went from 20,000 drives, transmissions, to 180,000. That's seals, oils, gears, maintenance. I can't tell you how, what we've done is our steel on steel bearing has friction. It already has a damping, and we've overcome that friction with our leverage drive. It works like magic. We've tested it out. Our bearing then pinches even tighter as the wind says, hey, I'm going to lift you off harder and harder. It actually increases with wind speed and force. Since we're not sharing purlins in 2P, but we can have a 3 landscape where 2 purlins, we have the same number of purlins, they're every 1.1 meters, but they're independent units, one panel, pre-assembled modules. Imagine if that actually slipped and it turned because it got hit with a really powerful wind gust. Well, all it did was spin, hit the ground on the bottom side and sit, And a day later, when that 1 in a 100-year storm or 1 in a 10-year storm is gone, the crew can go out and loosen it up and turn it back into position. No destruction. The wire's long enough that it handled it. This is an option. Our round torque tubes will hold in any wind. And of course, we could always go from a 4-meter to a 3-meter cord for the really high winds. The other option we have, and as I said, we are pinching our bearings, is that we can have an actuated locking system. Why have a drive at each post when all you need is a lock at each post? 2 patents issued and several pending. So again, these are both my cars. The one on the left is 2015. It's at that 1 megawatt site that's 17 years old on my first tracker for Shell Solar. It has all-wheel drive, and it's nice in the snow. That's my 1957 Ford Fairlane on the right. I drive that around here up in Lake Tahoe. It does not have 4-wheel drive, but in the wind, we don't need 4-wheel drive. We need just braking. We need holding. The car on the right will do just fine. It's much cheaper. It's old technology that's been around for a long time, and it works. EPC. This is why an EPC should probably invest in us, because I'm going to save you a lot of money down the road. I say a penny a watt. We know it's going to be more like 2, 3, 4 cents a watt when it's all said and done. Or you, as I said, there's a lot of companies out there that should M&A us because it really will be best for you. But an EPC should say, we will invest in you. We'll just do the round A, and you give us a special deal on the product. I got to make it simple, foolproof, loose bearings of simple alignment, optional field weld or field bolt. There's countries out there where they have a lot of welders that need work. And it would be much better to forego the holes and slots and just piece it together and weld it together like I did on that 1 megawatt Shell Solar project. There's a lot of safety improvement in this, especially with that standing platform of the trolley. And when the aisles are muddy, you can be on that trolley. If you pre-panelize, you can do that in an off-site tent, either non-union wages off-site, or you're in a tent over in the corner where it's 24/7 operation because there's no rain, or if it's blistering hot, you have at least some ventilation fans or maybe a little bit of air conditioning, and you get consistency. You will have the tooling and the setup so that every single panel has the same torque, the same alignment. Consistency drives reliability. So you'll read more into this later. Cost savings number 8. Again, what were we talking about? Sorry about this. The EPC. Yes. So this summarized everything I just said. Field weld option. That first system was field welded. You could see in the upper right, we had square torque tube in a round a round bearing race, which was an error because the 2 bottom corners of that square torque tube wore out very quickly. The round on round is a lot of surface area, a lot of friction, a lot of holding, a lot of non-wearing out. You just weld it and cold galv it. And you can, and especially if you go non-hot dip galvanized, just weld it out in the field. The main thing about the welding is you got to have a good set of inspectors, and you got to make sure the welders in some of those countries are truly wearing welding hoods and not just Ray-Ban sunglasses. This is field welded after 17 years. Opex, 30 years of operation. It's a simple system, easy to, just simple. O&M, you don't have 180,000 transmissions to check the oil and replace that leaking seal, etc. It's no obstructions, lots of access, robust and reliable. You have to, you cannot thin it out so much and then back it up with a whole bunch of drives. one PLC. That's simple. The PLC goes bad 30 years from now, 20 years from now. They're going to have another PLC with the same ladder logic or whatnot. No wireless net, no moving wires, no thousands of controllers and batteries in the field. A battery out in the field where it's super, super cold or super, super hot. And then agriculture option and this optional spin allowance. As I say, if the wind has some major gusts. In summary, that brings us back to $50 million per gigawatt. Let's just say for EPC, you bought us for $8 million, threw in another 2, that's $10 million. And in 1 gigawatt, you're going to get back 50. That's a 5 times return. Plus you have me on board if it's an EPC. We really prefer round A, and we will bring you a fraction of these savings. We're turning this into a very healthy M&A or an IPO, really. We have IP. We have 8 applications. So round torque tube's been issued. Imagine that, the best torque tube ever. A bolt-on bearing is issued. A weld-on bearing is pending. It's just like number 2. Slow purlins are pending. The winch cable pulley drive system, which is a work of art, pending. Our bearing race, that's where we have the 2 independent pieces that are bent and folded and twisted, and they just marry each other. One piece to make a full bottom half. They bolt together. The bearing, the control system, and which is one PLC and options for hard wiring or power line control. And then now the self-damping and self-clamping bearing. That's in process. Our IP people are writing it up now. These describe all the benefits of those patents, the status, and the benefits are both in cost savings and in reliability enhancement. Simplicity is the ultimate sophistication. I'm an engineer. I know how engineers like to have fun and build the Milton Bradley game mousetrap, more complicated. The boot kicks the ball, that rolls down the chute, that kicks the lever. No, you need the simple mousetrap that's reliable, uncomplicated, balanced. People have tried to lower the center of gravity of these trackers with special bearings or special torque tubes that bend down. We just tilt the 2 panels on either side down to 5, maybe even 7 degrees, and you get a low center of gravity plus excellent wind performance. Pre-assembled these panels, dispense them out onto the torque tube like a industrial Pez dispenser, and it gives unique aesthetics. Nobody has an up-down view like this. It's really going to win over some other stakeholders. Those neighbors that'll look at this will say, okay, that's pretty. And it's appropriate large. 3 years ago, there's a lot of talk about, see, you have to stay 2 meters. The wind's going to destroy it, as that tracker fell apart in Jordan. And then everybody had to go to 2P because of the bifacial modules. Well, we always stayed 4L, and now we can go 2P, 3L, 4L, 5L. We were prepared. We are prepared. We've tested. We're ready for 5.2 meters. That's 30% more power, more energy out on a row. That lowers that dollar per watt cost by 25% alone. So pre-panelized, this is what we did in 2004. It worked like magic. And this is how you want to do if you're truly construction scale. Putting one module on at a time with the guys standing on ladders and is silly. So some examples of, here's a 2P on the left, 2P going on the tracker on the right, a 3L and a 4L. The 3L does make the middle module flat. That is with a large format module. The same on the left are both for large format, but these can be small format. So imagine the one on the right. If it's large, lower right, large format, that's 3.9 meters. That's basically 4 meters of what we have today with 2P. Or with a small format, it would be 3 meters, which would be much healthier in a high hurricane, high wind area. Some examples, it shows on the right how the purlins fixed to those 4 modules at the quarter points. and we can raise those. I'll talk about that later for bifacial, but these are options for 2P, 3L, 4L. And as I said, we can either go to a 5L with a small format module, but it would have a flat module in the middle. Here's a comparison of 3L and 4L, same large format module. Yeah, here's some details. I'll go through these quickly. It just shows what the different sizes, whether it's small format, large format, landscape or portrait, and then monofacial, meaning covering the torque tube, or bifacial, set off of the torque tube so the torque tube does not shade it. This shows where the purlins would go for those examples, and this again shows where the purlins would go for those examples. If we do have bifacial, first off, the PV is already an inch and a half, 5 centimeters or so, 4 centimeters above the frame. It's at the top of the frame, so you have some clearance from those purlins underneath. And then, but we could, on the bottom picture, you could show that we could add spacers to those bifacial modules. So you have about a 3-inch, say 7, 8 centimeter clearance, so the light can come in from the side to give you some additional output from the bifacial backside reflection. Key facts, you can read through this. We are pre-sales, but we have 100 to 200 megawatts of previous sales. When I worked for a company and I brought them a tracker, we tested this prototype, 2 issues, 5 pending, and we're Nevada-based, and it's all about single-axis tracker. I have done better fixed tilt systems, but oh, sorry. So what I really wanted to do, I didn't want to read all this, and I wanted to highlight it here. So we are a technology startup, proprietary single-axis tracker, experienced engineers, very experienced with business discipline. You know what that means. And 2 prior trackers and 2 issues patent, 5 pending, and really it's about to be 6 pending. It's a fresh approach with extensive experience, simplicity, that up-down PV attachment, and a heritage of simplicity that then we added simplicity to that heritage. Best value approach. I've seen many trackers fail for all the reasons over a long career. Our vision is faster, better, cheaper, and not to cut corners, but to really improve in robustness and absolute reliability. The 2 bottom pictures show the bottom left is my first tracker. That's a 6 modules, 3.3 meter cord, and the one on the right is a 7 megawatt with non-hot dip galvanized post, I-beam post. That's 3 meters wide. That was for O Solar. So best value to C&I and PV stakeholders. What are the market opportunity? It's large, and you know it, and you can read it all throughout here. And we're ready for the large format bifacial solar modules. We tested our prototype. First, we got the seed investment. 2017, 600,000. We're now up to recapped up to 900,000, gathering additional IP, faster, better, cheaper ideas, improving, and setting up for final testing. We tested these 2 size test rows and learned a lot. And now we're seeking round A financing to do the final development, final test, all the bankability studies, etc., and introduce us to the market. You're really going to get good traction by considering all stakeholders. And so we are in the 15 cents per watt range like everybody else. But of course, everybody else, they claim 12 cents and whatnot, but it really turns out to be 28 cents a watt when all things are done, adding on ground wires and all the EPC of adding on shock absorbers and multiple drives, you name it. Go to Maddox to market strategy. You can read this. We have a plan, but it's still developing, and the market is conquerable. And it's most conquerable when you have a better mousetrap with truly cost-saving ideas. This is our plan with that $2.5 million, and how we're going to ramp up market entry. Very conservative with 10 megawatts, 50, 200, eventually getting to a gigawatt in 5 years' time. I have friends out there with PPAs wanting to use my tracker. They know me, they know this tracker, and so we could get sales very quickly. The ask is $2.5 million for 25% equity. That means ownership. We've raised 800 up to date. We have another 100 potentially coming in, and this is what we're going to do: get a bankable design, market it, and sell it. Contact me at the email address below. 44 minutes going on. Let me see. This is a round A budget. You could go through detail on this. We offer value throughout, and that's the end of my talk. I just want you to know that there are 6 appendices. It shows some relative sizing and etc. And that is the end of my talk. I hope that you saw in the video a lot that was in here, the options of 2 different types of bearings, the options of 2P or multiple landscapes, the ability to put module on at a time, or the modules pre-panelized, which really is how you're going to build 100 megawatt, 10 megawatt, and definitely gigawatt size farms. Thank you very much for listening. Again, I want to stress, we are in need of round A. We are seeking round A. This is an excellent opportunity. We will make you money. We will entertain an M&A, but we prefer round A because we see an upside of making a lot of money on this. Now we're ready for your questions, and thank you for your attention.
Excellent. Well, thank you very much, Robert. Just another quick reminder, obviously we can take questions now. We have a bit of time left over for that. And again, just another reminder, the presentation, including links to all of the videos and appendices, which Robert mentioned there, will be available after the presentation as well. Rob, I have a few quick questions. We've obviously been monitoring them as they've come in from the audience. I think just to start with, we'll have a few questions on the round A and the M&A that you speak of. Is there any indication from yourself what and or who comes with an M&A? So is that team-based, the technology, patents, that kind of stuff?
Yes, if it happened to be a round A, I've got a resource of contractors and engineers and test houses out there that I will use, and I'll be with that as well. But if someone did fully acquire us through M&A, I would join that company with a minimum contract. And really, I'd like to finish out my 50-year solar career in 2029 by saying I've got many gigawatts out there. So I will come aboard, help with the technical, the final development, the launch, and then sales. I have a very large Rolodex, so I come along.
Excellent. And I know you spoke about the kind of plans and market. Is there any prospective time frame for that? So is there when do you want to start seeing trackers in the ground?
The plan is 18 months, but I believe I can get it in 12 months with a few friends who are willing to use it in the post-prototype stage, as well as we do have a little bit of budget in there for assistance in early projects to the buyers, so that customers can come and kick the tires. So 12 to 18 months.
Perfect.
If I don't want to say if an M&A acquired us and they were a racking or tracker system and they had a lot of resources internally, we could probably do this in as short as 6 months. It's pushing it, but we've gone so far along. And if they've got a lot of internal resources, then we hammer this just like we have to get a satellite up in space at a deadline launch.
Perfect. I'm a little bit cautious of time, so I'm going to move on and tackle some of the technical, or at least product-related questions, because we had quite a few of those as well. This one here, is there any special tooling that's required to manufacture the steel parts that you mentioned today?
No, the beauty of this is that this can be manufactured anywhere. Anybody can make a round tube, torque tube, and etc. There's a few small custom toolings. One for if we have light gauge purlins, that would be the cavity press. That's easy enough. Or if our purlins are made out of plastic, that would be injected molding tooling, which can pretty much be made any manufacturer. So no special tooling. We've designed this to be very easy to make around the world too. So if you want local content, here it is.
Perfect. And obviously local content seems to be propping up in more than a few auctions and tenders that we're seeing around the world. So a really important factor there. Is there any impact on the product's lifetime by skipping the hot dip galvanizing process at all?
No, I mean, if you were to do it in the Marshall Islands, then yes, you've got to triple hot dip galvanize it. But in most areas, even in Abu Dhabi, where it seems humid, if the metal's thick enough, it doesn't wear through. And you will see that on bridges that are made without galvanization or painting, and underside of trains, the tracks on tanks. So if any thin part, if we go with light gauge steel purlins, those need to be galvanized. But all the thick pieces, they're so thick, they're just going to develop a rust patina, which actually looks good in a brown dirt environment.
Fantastic. And I'm going to try and capture quite a few questions here. What's the kind of state of play with cleaning solutions? Have you demonstrated any or trialed any with slanted panels? Does the system work with robotic solutions at all?
Yeah, I mean, first off, we did a test in Abu Dhabi. Simple broom brushing gets you 99% clean. The water will get it another 1%. Robotics, they just ride on the rails of the module frames. And so any robotic can clean it off. You could tilt it up and down so that you could have a water sprayer that just goes along and sprays the roads off as needed. In some environments where it's very dusty, like the MENA, you will run that robotic duster almost continuously, or at least once every 2 weeks. So it's got that in mind too. As I say, I've designed for material, Capex, EPC, and Opex. That's 30 years of O&M, and that's weeds, cleaning, maintenance of moving parts, etc., and minimize all of that, minimize the difficulty, the complexity of all of that.
Perfect. And lastly, I think just again, cautious of time a bit, I'll try and capture quite a few questions here. Has there been any hurricane loading analysis or wind tunnel testing on the product?
We went through CPP wind tunnel, but that was with our 4-meter coplanar design. With the up-down, no, we have not. We've done some analysis. We did test it out in the field when we had high winds. And no, we'll go through, that's part of the plan. The $2.5 million plan is go through wind tunnel testing again and prove what we suspect and have partially proven already.
Excellent. Well, unfortunately, that is all we have time for today. I appreciate there's been tons of questions that we haven't had time to get around to, so we will endeavour to have those answered privately. So if we do obviously have your contact details, we'll look to get in touch. The presentation and recording will be available shortly as well. So once again, keep your eyes peeled on PV Tech and in your inbox. A huge thank you to Sun Install Solar for supporting the webinar today, and for Robert for presenting all of the material in case you missed any at the start. Everything will be available shortly after the presentation. Thank you indeed, everyone who's attended and given us their attention today, and we hope to see as many of you next time. Thank you.
Thank you, everybody.